You are welcome to my class. In today's class, we are going to do 2 or more calculations on vibration of air columns in pipes, which can be open or closed pipes. I have illustrated how to draw standing wave and also the formulas related to standing waves, the fundamental frequency, the first overtone, second overtone for both open and closed pipe. Ensure you watch the video before coming to the calculation for easy understanding. Is that clear? So now let's look at number 1. The question says a pipe closed at one end. Supposed to know now here is what? A closed pipe. Is 100 centimeter long. If the air in the pipe is set into vibration and a fundamental note is produced, calculate the frequency of the note, given that the velocity of sound in air is 340 meters per second. So what are we looking for? Fundamental frequency, F0. Solution. So you have forgotten your formula, quickly do, since it is closed pipe, quickly do something of this. Your node, remember that your node is always what? The node for the fundamental frequency is always at this point. So I have my incident, I have my reflected. This is a quarter, right, of what? A full wavelength. Something of this. From here to this place is full wavelength. Half of it from here to this place is half. And half of this, which is quarter, is lambda all over 4. So this is what we have here. So the length of the air column here is what? L is lambda all over 4. And we have from this place lambda to be equal to 4L. Quickly remember your formula. V is equal to F lambda. In that case, I have V is equal to F times lambda is what? 4L, where F is equal to V all over 4L. Here is my fundamental frequency or fundamental note. So having known this, quickly from here, I have V is given to be 340 meters per second. And the length of the air column is given to be what? 100 centimeters. So L is 100 centimeters. Since this one is in meter per second, I'll convert this centimeter to meter. The equivalent of centimeter in meter is, of 100 centimeter in meter is 1 meter. So I'm looking for what? F0, the fundamental frequency. So using the formula, right, I have F0 is equal to V all over 4L. The next thing is to substitute your values. I have V is 340 all over 4 multiplied by L is 1. So that will give me 340 all over what? 4. Here 2, here will give me 17. That is going to be 170, right? So that will be equal to 170 all over 2, which is equal to B 85 Hertz, the unit of what? Of frequency. Let's see number 2. Question number 2 says a pipe closed at one end is 1 meter long. The air in the pipe is set into vibration and a fundamental note of frequency 85 Hertz is produced. Calculate the velocity of the sound in the air. I just turn around the first question in order for you not to panic in case if you ask to find what? Velocity. So solution. So since it is open pipe, a closed pipe, I will quickly write my formula that F0 is equal to what? V all over 4L. Don't forget. So here we are given that fundamental note is 85 Hertz and the length of the air column is 1.0 meter. Then we are looking for what? Velocity. It's as simple as this. So which implies F0 is V over 4L. Putting the values, I have what? F0 is 85 is equal to V all over 4 multiplied by 1. So this will give me 85 is equal to V all over 4. V is equal to 4 multiplied by 85. That will give us 340 meters per second. So you can see, you can make L subject to the formula, you can make V subject to the formula, and you can make what? F naught subject to the formula, as the case may be. If the fundamental frequency of a closed pipe organ on a day when the speed of sound is 340 meters per second is 170 hertz, then the length of the pipe is, so we're looking for the length of the pipe. Now, solution, we have the speed V to be equal to 340 meters per second, and the frequency, the fundamental frequency is 170 hertz. You're looking for the length of the pipe, which is not given. So since it is open pipe, for open pipe, we have F naught is equal to V all over 4L. Correct? So you have bring out your formula. The next thing is to what? Input your formulas. I have F naught is what? 170 is equal to V. The velocity is 340 all over 4 multiplied by what? The length. Is that clear? The length. So, which implies I'm going to have 4L multiplied by 170 is equal to 340. Then divide both sides by 170. For now, let's do like this. This one will go with this. I have 4L is equal to 2, right? So L is equal to 2 all over 4. That will give us 1 all over 2, which is the same as 0.5 meter as the length of the pipe. I hope this is clear. Good. Now, let us quickly look at questions that involve open pipe. The question says, an organ pipe of length 40 centimeters opened at both ends, sound its fundamental note. Neglecting end corrections, we are going to talk about end correction soon. Calculate the frequency of the note. The speed of sound in air is given to be 340 meters per second. We are given V. We are given length. Now you're looking for fundamental frequency. Remember, they said it's fundamental note. They now say you should calculate the frequency of the note. That implies you're looking for fundamental frequency. So, in question like this, I advise you to know the fundamental frequency for an open pipe. Since the pipe is open at both ends, it shows that this is an open pipe. Is that clear? So, if you don't know, don't panic. Remember, we have video on this. Please, if you have not done that, have not watched it, ensure you watch it. Since you're talking about fundamental frequency of open pipe, so it has one node. So here, if here is the incident, here is the reflected, here is the node, antinode, antinode. So we have the length of the open pipe, open column, or the length of the air column, L, is given to be lambda all over what? 2. Remember this. As well, remember that V is equal to F lambda. We explained this in detail in that video. So from this, length is lambda over 2. You can make lambda subject to the formula, which will give us 2L. So that I have V is equal to, the frequency I'm going to get from this one is known as fundamental frequency. I use F naught multiplied by lambda now is 2L, 2L. So if I make F naught subject to the formula, I have V all over 2L. If that is the case, remember they said V is what? 340 meters per second, and the length L is 40 centimeters. Since V is in meter per second, convert this one to what? Meter as well. That will be 40 divided by 100. Remember that 1 meter is equivalent to what? 100 centimeter. That will give us 0.4 meter. By the time this one cancels this, you have 0.4 meter. Now put that inside this formula. I have F naught is equal to V is 340 all over 2 multiplied by what? Length is 0.4. That will give us 340 all over 0.8. That will be 425 hertz. So this is all about this type of question. If you look at this next question, you see is relating the wavelength, the length of the pipe, and the first overtone. This is not like the previous question where you are talking about finding the fundamental frequency. So we are looking at the relationship between the wavelength, the length, and first overtone. So solution. If you remember, our first overtone is second harmonics. For a closed pipe, quickly remember this. For a closed pipe, our first harmonics, which is our fundamental frequency, is always like this, right? And we said the length of the air column is equal to lambda all over 4. So this is what you're going to relate. This is for first harmonics. Second harmonics, which is equivalent to what? First overtone. Ensure you watch the video on how to draw the standing wave pattern on closed pipe. So for second harmonics now, how many nodes? 2 nodes, right? I have 2 nodes. So, right? This is how we did it. And we said that the length of the air column L is equal to 3 lambda all over 4. So the question is asking us to what? To find the first overtone. First overtone What is the wavelength of the first overtone of a note in a closed pipe? So you're looking for the wavelength of the first overtone. So first overtone, we have L is equal to 3 lambda all over 4. Is that clear? So, and in this case, we are given that the length L is equal to 3 centimeter, which is equivalent to 0.33 meter. And what else? That is all. So we substitute that, or better still, we make lambda subject of the formula. When I cross multiply 3 lambda times 1, I have 3 lambda is equal to 4L, so that lambda will be equal to 4L all over 3. So the next thing is to put the value. I have L, right? 4 multiplied by length is, let me work in centimeter, 33 centimeter all over what? 3. Is that clear? So 3 in 33 give us 11. So I have 4 multiplied by 11, which is going to be 44 centimeter. So this is all about this type of question. So the length, the wavelength is equal to 44. Look at it critically and see how I relate it.